Welcome, everyone. This is Michael Forrester and Sanjeev, and we are here. Oh, wait, looks like it's starting in about 10 seconds, actually. give me just 1 second here. We're just going to pause for one moment just to make sure everyone's caught up with us. All right, ready? 3, 2, 1. There we go. Looks like the live stream now is on for LinkedIn as well. So welcome, LinkedIn users. Hi, this is Michael Forrester. This is my co-creator, Sanjeev. Say hi. All right, so we're here today for episode 4 of 5. For us to talk about technology services inside of AWS. So this is all around the AWS Cloud Practitioner Program. So Sanjeev, you can go ahead and share the slides, and let's go ahead and take a look. Okay, so a reminder that this is actually episode 4 of 5, and unlike the previous episodes, there will be an announcement at the end of this call. But this is a reminder that this is a 5-part series, and so as we go through this, you'll see that today is the 4th of the 5th. So we're going to do today, Thursday, and then we're going to have our final episode next Thursday at the same time. Okay? Next slide, please. All right. So this week, we're going to talk about services on AWS, particularly VPC and all of its amazing friends, and EC2 and other compute options that might be worthwhile. We are in this session today also going to cover a few practice exams, and we're going to give you just a little bit of a preview in that basically we're going to talk about billing and pricing next week with AWS, which is kind of a hot topic, particularly in 2023. Next slide, please. So a reminder that not only is this part of a class that KodeKloud has in its subscription called AWS Cloud Practitioner, which will actually help you prepare and pass the AWS Cloud Practitioner exam with AWS, there is actually a 20% off coupon that we show on this live stream that you can use to get a discount off the entire subscription, right? Not just this class course. All right, and there's the link right there, and the code's below, links right there. So you can get clicked in right into the course and go ahead and subscribe to our service. Next slide, please. Now, I didn't mention this before in any of the previous episodes, so I want to make sure I mention it now, is that we do have this amazing feature as part of our subscription called the AWS Soundbox Playground. And this is part of what we provide in KodeKloud to kind of make sure that we are creating high-quality DevOps and cloud engineers. And so this is something that you get as part of the subscription that actually literally gives you a playground to play, launch, and explore AWS. Now, the list of services is not unlimited, but there's about 20 to 25 services that you can literally get a 3-hour playground where you can go in and launch your own EC2 instances. You can launch your own RDS instances, your relational database instances. You can mess with VPCs. And so just know that this is here. This is all in your browser. You do not have to set this up in your own AWS account, and it's all kind of structured and set up for you. So just a reminder that this is here for those of you who are looking to explore and deepen your engagement with AWS services. That all being said, I'm now going to hand it over to Sanjeev, who is now going to talk about the networking and compute services that we mentioned that we would cover and skim in this particular episode. All yours, Sanjeev.
All right, guys. So yeah, we've got a couple of different features and technologies that we're going to cover today. And what we're going to do is we're going to start off with by going over the AWS global infrastructure first. So we're going to start off at the absolute basics of AWS here. And so first, we got to ask ourselves, what exactly is the AWS global infrastructure? Well, you can think of it as the building blocks of AWS. So it's important to understand the different components that make up AWS infrastructure so that you can build highly resilient and fault-tolerant architectures. And so we're going to learn about regions. What are they? We're going to learn about VPCs, availability zones, and how they all kind of fit together when you're designing your cloud environment. So we'll start off by going over regions. Now, a region is a geographic location where resources can be deployed. So when you want to deploy your application to, like North America, then you would pick a North American region. Or if you want to deploy your application in Europe, then you get to deploy it in Europe. So AWS has all of these regions scattered across the globe, so you get to specify exactly where you want your application deployed. Now, each region is designed to be isolated and fault tolerant from other regions. So what that means is that if there were to be an issue in one region, it's not going to impact the other regions. And they've designed that specifically so that, one, you can build in redundancy and high availability. So that way you can potentially deploy your application in multiple regions. One goes down, that's okay. Your other region won't be impacted. Now, on the screen here, we've got it's just a little map of all of the different regions that are available for you to use on AWS at the moment. And it even shows the ones in yellow that are, planned to be deployed eventually in the future. So there's roughly about 31 regions or so, give or take a few. But if you want to take a look at all the different regions that AWS has to offer and more information about them, especially when it comes to the different services and features that they have available, you can always take a look at the AWS documentation to get some more information on those guys. Now, within a region, there are what we call availability zones. So a availability zone is one or more discrete data centers with redundant power, networking, connectivity in an AWS region. So you have regions, and then within the regions, you have multiple availability zones. And so the whole goal of an availability zone is to provide redundancy within a region. So let's say that you have an application that's deployed in a region. And if you deploy your application to one availability zone, the problem with this is that, well, now since your application is only deployed in one availability zone, if that availability zone goes down, the entire region goes down. So the entire region essentially gets impacted because you only decided to deploy in one availability zone. And so that's why when you're building out your cloud environment, you want to deploy your application across multiple availability zones. And that way, if one availability zone goes down, it's okay. Your application's still up and running in the other availability zones and the entire region doesn't go down. So that's why availability zones exist. They're here to provide redundancy within a region. So now we're going to move on to edge locations. And I want to kind of give you kind of the problem statement of why edge locations were ultimately created. So let's say that we deploy a application or web server onto a specific region. In this case, we deployed it onto some North American region. And one of our customers in America decides to, send a request to our web server. So he sends the request to the web server. Everything works, no problem. Now, the problem arises when, let's say we have a customer all the way in Asia and they want to send a request to that same web server. Well, now that request has to traverse the entire globe to actually get to our web server. And so this long distance leads to higher latency. Some applications can tolerate that, but for latency sensitive applications, this is a little bit of a problem. And so to address this issue, AWS created what is called edge locations. So these are, smaller, you can think of as smaller regions that perform a very few select services that are scattered across the globe. And the whole idea is that these regions, since there's more of them and they're all across the globe, you can get your application a little bit closer to your end customers. So once again, if we take a look at that example, we've got our web server running. And now our web server is actually going to push our files, our apps, to all of these smaller edge locations. And so a user, he can still send a request to the original web server. And if that user is in North America, that's fine. It's going to be very close. But for users in India, they can now send requests to a specific edge location, which greatly, trims down the latency because they only have to go a short distance because there's a lot of these edge locations scattered across the globe. And so that's really the main idea behind edge locations. They are predominantly used for CDN services. There's a couple of other features, but you don't get all of the same feature set that you would have in a regular region. All right, so now let's just quickly touch on networking. So when it comes to networking in AWS, the main feature that we have available is VPC, Virtual Private Clouds. So what is a VPC? It's a secure, isolated network segment hosted within AWS. And so what VPCs do, and what is one of the main benefits of them, is that they help isolate computing resources from other computing resources in the cloud. So it not only isolates your resources from other AWS customer resources, but it also helps segment out, maybe you have different applications or different organizations that are deploying different resources, and you want to make sure that they can't talk to each other. This can all be handled by VPCs. That's what allows you to isolate all of your infrastructure. And with AWS, they give you full control of networking in the cloud. So you get to define all of the subnets that you want to use in the cloud. You get to specify the IP addresses your servers use. You get to define the routing table itself. So you get to specify what path does your traffic take within AWS. You get to configure different firewall policies so that you only allow the traffic that you need to allow, and you don't allow requests that you have no use for. And you get to define gateways, which kind of handle how traffic gets in and out of your VPC or the cloud. All right, so that's, we covered global infrastructure, a little bit on networking. Let's now move on to the various storage services in AWS. So there's 3 types of storage that we primarily use. We've got block storage, file storage, and object storage. And AWS is going to have a specific service for each one of these different types of storage. And we're not going to spend too much time going over exactly how each one of these works. We'll just kind of go over them at a high level. But we'll start off by going over block storage. And for block storage, the service that AWS provides us to help us have block storage in the cloud is going to be Elastic Block Store. And one of the benefits of block store is I want to just kind of talk about an instance store. So how does our EC2 instances, how do they actually store data if we weren't using something like EBS? And that is that when you provision an EC2 instance, a instance store gets provided for you automatically. And so instance store is a temporary block level storage for that instance, but it's important to understand it's temporary. So if you were to terminate that instance, guess what happens? You also lose the instance store. So you no longer have that data. It's gone forever. And so with EBS volumes, what we can now do is we can create an EBS volume and we can attach it to an EC2 instance. And so EBS is going to give us a form of persistent storage. So now if we were to terminate the EC2 instance, that's okay. The EBS volume remains, and we can attach it to another EC2 instance with just a couple of clicks on the AWS console. So that's one of the benefits of EBS volumes. Keep in mind, just some things to note, for the exam. EBS volumes do allow you to mount them to a server, and you can also boot from them as well. So you can actually install an entire operating system on your EBS volume. Now, the next storage type is file storage. And so the service that AWS provides us that's of the file storage type is Elastic File System, or EFS for short. And so the idea behind file storage is file storage stores data in a hierarchical structure of files and folders. So it stores data just like your computer stores it in files and folders. But the great thing about EFS, or file system storage, is that it can be accessible remotely. So you don't have to be physically connected to that storage instance. You can access it over the network. And when you access it over the network, you can perform all the same operations that you can with a file system that's directly on your computer. So you can create subdirectories, you can store and access a variety of different files on that file system. And file storage, just like block storage, it can be mounted, but you can't actually boot from it like a block storage. So you can't install an operating system. So that's one of the differences between file storage and block storage. Is block storage you can boot and mount, file storage you can only mount. And with file storage, because it is accessible over the network, multiple users or clients can access the same data at the same exact time. So they all can be connected to the file system, and they all can make changes in real time and work on that file system. All right, so now we're going to move on to the final storage type, which is object storage. And so AWS has a service for that as well, and it's called S3. And so for object storage, the whole idea is it stores objects. And so what exactly are objects? Well, objects are nothing more than files. So you can store any type of file in object storage. It doesn't matter if it's traces, logs, your CI pipeline artifacts, images. You could store any type of file in object storage. It's meant to just store individual files. So if you're kind of having trouble understanding like what that means, think of it as like a very fancy, feature-rich, Google Drive or Dropbox, right? You upload files, it stores them, you can retrieve them whenever you'd like. Now, with object storage, specifically S3, it's important to understand there's no folder structure like there is with the EFS. So it's a flat file structure. Everything is in a single folder. And because of that, because everything's in a single folder, it means that it can't be booted or mounted. So it's only used for accessing, if you need to get files, you can retrieve the files. If you want to upload files, you can do that. But there's no folder structure, so you can't boot or mount it like you can with EFS or EBS. But like I said, object storage, great for storing logs, media files, and really any type of file that you want to store. All right, so now let's move on to AWS's compute services. So they've got a couple of different compute services. I think the one that most people are familiar with and start out learning is going to be EC2. But when you deploy an application, ultimately, you need servers to actually run your application. So normally you would, create servers, and then you would, get your code on those servers and actually run them on them servers to actually deploy your application. In the cloud, you'll see that it's very, very easy to provision a server on AWS. Really, all it takes is just a click of a button, and you can automatically have servers provisioned on the cloud. And you can scale them up as much as you want, scale them down as much as you want. And so at that point, you can take your application and then deploy onto the servers that are running on your cloud, which are virtual machines, but they operate just like any other physical server. And just like with buying a physical server, you could specify all the specifications for your server or your virtual machine. So you can say how many CPUs you want, how much memory do you want, how much storage you want. You get to specify all those details and have it automatically created on AWS. And like I mentioned, as easy as it is to scale up on AWS, all it takes is just a few clicks of the button to scale back down if you'd like. And so that gives you a lot of flexibility versus, working in a traditional data center. If you need a new server, then you're going to have to go place an order for a new server, then get it racked, configured, cabled, and everything like that. Here on AWS, you just click a button, you get a server instantly within, takes a couple of seconds, maybe minutes at most. But this service, as I mentioned, is called EC2. So this is their main compute service. The next compute service I want to talk about is Lambda. And so AWS Lambda is a compute service that lets you run code without having to provision or manage servers. And so you take your code, and the only thing you have to do to get this deployed on AWS is you just upload your code to AWS, and AWS is actually going to create the servers for you. You don't have to do that, and it will then deploy the code onto those servers automatically for you. And so this is what's referred to as AWS's serverless offering. And it's important to understand, a lot of times people get confused by the name serverless. It doesn't mean that there's no actual servers. It just means from your perspective as the customer, you don't see any servers. You don't have to manage servers. You don't have to provision them. AWS handles all of that. So it handles server maintenance, scaling, capacity provisioning, and logging. It handles all of that. You just have to worry about uploading your code to AWS. Now, the final compute type that I want to cover is going to be with regards to containers. Now, if you don't know what containers are a tool that allow you to package applications and all of the necessary files, libraries, and dependencies the application needs to run. So you take, your source code, any other extra dependencies, and you bundle it up into a portable little container. And since the container has everything the application needs to run, you could take a server and you can deploy that container to that server, and you don't have to do anything else. Your application's up and running. You don't have to configure anything. You don't have to install anything. You just deploy the container and your application is good to go. And so if you guys aren't too familiar with containers, I like to just think of them as very small, lightweight, portable virtual machines that you can use to deploy your application. So there's two different services that AWS has when it comes to managing containers, right? They have two containerized based services. The first one that I want to go over is Elastic Container Service, or ECS. So ECS is a fully managed container orchestrator service that helps manage, scale containerized applications. So if you don't know what a container orchestrator is, it's really the brains behind the operation. So it's the one that makes the decisions. It handles deploying your containers. It handles watching them, monitoring them. And if one of them goes down, it's going to be the one responsible for, kind of booting it back up and just making sure that everything's working, right? It's the decision maker. And so with ECS, it's completely managed by AWS. So they handle all of the infrastructure for ECS. You just have to provide the configuration for what you want deployed, and then ECS and AWS will handle the rest. The physical containers, though, right? The containers themselves are going to run on EC2 instances or Fargate. And so these are things that usually you have to configure yourself, right? AWS handles ECS, but if you want to deploy the containers on EC2 instances, well, then you're going to manage the EC2 instances. Now, one thing to note with ECS, it is a proprietary software, so it's specific to AWS. And that means it's only on AWS. And so if you migrate to another cloud like Azure or GCP, it's not going to be available. They'll have their own alternative, but it will add some challenges when it comes to migrating over. Just something to keep in mind when deciding on what is the best containerized or container orchestrator for your organization. The other containerized service that AWS provides is EKS. So EKS is what's referred to as a managed Kubernetes service. So Kubernetes is just a open source container orchestrator. And when it comes to Kubernetes, right? Normally when you deploy a Kubernetes cluster, you're going to have a couple of control plane nodes, which once again, very similar to ECS, where it's like the brains behind the operation. And then you have the worker nodes, which are just there to run the containers. And so normally when you deploy a Kubernetes cluster, you as the user are responsible for managing both the control plane and the worker nodes. And managing the control plane and the master nodes is usually not the most trivial of tasks, right? You're going to have to scale them, make sure they're deployed in a highly available manner so that if one goes down, you still have a couple of other control plane nodes. Properly securing it, that's another problem. Taking backups. So these are all things that you'd have to do normally. Now, with EKS, what it is it's a managed Kubernetes service. So AWS manages Kubernetes for you. But what exactly does that mean? Well, it means AWS manages the control plane. So they handle all of the control plane related tasks. They handle deploying the control plane nodes. They handle, it makes it very easy to do backups. You could just define that with a couple of settings or knobs within AWS. So they handle all of the control plane nodes. However, the users still have to be responsible for managing the worker nodes. Unless you decide to use something like Fargate, which then you're kind of offloading the responsibility of the worker nodes onto AWS as well. But just important to highlight, EKS managed Kubernetes service that handles all of the control plane nodes for you. And so some of the benefits of EKS is that it helps run and scale the control plane nodes, and it's going to do that across multiple availability zones. So they automatically do that for you. It'll scale the control plane instances based on the load. And what's really nice about EKS is it integrates with all of the other AWS services. So you can set up IAM for authentication. You can configure Elastic Load Balancers to handle all of your Kubernetes services. You can integrate with ECR as well as many other services like the secret store and things like that. These are all things that integrate nicely with EKS because they're all within the AWS ecosystem. And just so to summarize with containers, containers are a tool that allow you to package an application and all the necessary files, libraries, and dependencies the application needs to run. Container orchestrators deploy, manage, and scale containerized applications. ECS is just a simple managed container orchestrator provided by AWS. And that's really kind of the main difference between ECS and EKS is ECS. It's designed to be very simple and easy. And Kubernetes is an open source container orchestrator. And EKS is a managed Kubernetes service where AWS manages the control plane for you. All right. And so that's going to wrap up what I wanted to discuss. And so I'm going to pass it over to Michael, and he's going to walk you through some practice questions for you guys to prepare for the Cloud Practitioner exam.
Awesome. Thank you, Sanjeev. Okay, excellent. So you got a good overview there of, fundamental services in networking, fundamental services in storage, and some compute. So that was spectacular. So let's move on, and let's just do a few practice exams with a few minutes remaining. And then we're going to talk about our special announcement and then get into some Q&A. So if you don't mind, let's go to the next statement. Okay, so as we've done before in past episodes, A, B, C, or D for 1, 2, 3, and 4, which of the following statements is true regarding availability zones in AWS based on what Sanjeev actually just covered? So go ahead and type in the chat. What do you think is appropriate here? Are availability zones a single point of failure? Do they share a single point of failure? Are they physically isolated from each other within a single region? Are they only available for use in specific regions? Or are they simply multiple instances running on the same server? What do we think? So, Sanjeev, what do you think? You just talked about this. You probably know the answer right off the cuff. What is it?
Well, let's take a look at all of the different options. So the first one, availability zones share a single point of failure. Well, when we discussed availability zones, I think the idea was that it helps build redundancy of some sort. So most likely it's not going to be that. I mean, it's even in the name, availability zone, right? High availability. You take a look at the second one. Availability zones are physically isolated from each other within a single region. So that looks promising, right? The whole idea is that availability zones are in a region and they help kind of give you extra redundancy. Availability zones are only available for use in specific regions. They're available in all of the regions. And availability zones are simply multiple instances running on the same server. That doesn't even make sense. So most likely
Yeah.
it's going to be B. And so if we
Okay.
take a look,
Voila. Yeah, you're correct. B. And I see that most people in chat also did that as well, right? We see Anaset and Sandesh and Willajai have all posted that the B was as well. Excellent. Okay, well, let's go on to the next question then. All right, so this one is a little subtle. It's like, what is the main difference between installing databases onto an EC2 instance, like a virtual machine, versus using AWS managed databases like RDS, DocumentDB, DynamoDB, etc.? Like, what's the difference? So I'll take this one. So we've got 4 options here. So just like last time, A, B, C, or D, please go ahead and post your answer. Challenge yourself. But the first one is that managed databases provide automatic software patching and upgrades, while databases installed on EC2 require manual updates. That looks promising, as you just said, Sanjeev, about the previous answer. Databases installed on EC2 offer better performance and scalability, while managed databases have limited capacity. I don't know about that, considering that the Amazon Prime Day that just ran was like 10 billion transactions on DynamoDB. I think you could argue that while you can tune performance on EC2, managed databases do actually have great capacity as well, especially if you're willing to pay for it. And then number 3, managed databases allow for greater customization and control over database configuration, while installing databases on EC2 is a one-size-fits-all solution. If anything, I would argue the reverse, actually, is that EC2 allows for greater customization, which is one of the main reasons you would use it, whereas managed databases have just a slight more limitations on that, particularly depending on what flavor you use. And then number 4 is installing databases on EC2 is less expensive than using managed databases, which require additional fees for maintenance and support. Nope. If anything, actually, it's probably the reverse. Although, if you do a cost comparison, it's very interesting to see, if you throw in the operational skills, how much less costly RDS can typically be compared to managing your own EC2 instances. So I see that a bunch of people have put answers in there. And it looks like there's some level of agreement or consensus, right? Is that maybe 1 is the answer, managing databases with automatic software patching and upgrades, while you have to fully manage your EC2 instances. So let's see what the next slide shows. Yeah, so number 1 is the answer in this particular case. Now, you're going to get questions like this, by the way, on the exam. So just know that this is actually a very common scenario-based question where they want you to evaluate the difference between 2 general options. Next slide, please. All right, question number 3. Which AWS service provides automated event-driven computing, serverless architecture, and automatically scales the applications that run on it? Sanjeev, I'll let you take this one.
All right. So here, I think the key word to start out with, just to make things easier to rule out the wrong ones, is you take a look at computing, right? Event-driven computing. So what of these services do we know that are not even compute related? Well, we know RDS is a managed database service, so that's not really what would be classified as a compute service. And we know that S3 is a storage service, so that's probably not it. So it really comes down to Lambda and EC2. These are probably the only 2 reasonable options, just based off of that first couple of words. But then it focuses on serverless architecture and automatically scales up with applications. So EC2, that's just a virtual machine in the cloud. It's not serverless. You have to manage it. And I don't think it automatically scales up regularly just with EC2 without using any other extra services. So it's not going to be EC2. It's going to be Lambda. So Lambda is AWS's serverless offering. And
Excellent.
if we go to the next slide, yep, we could see that, yes, it is in fact the correct answer.
Perfect. And I saw that Omar and Christian and others all publish their answers in there as well. So we have a large amount of consensus that Lambda is indeed the serverless service, right? Great. Next slide, please. Okay, which of the following statements accurately describes a public subnet in an Amazon VPC, not just a private subnet, right? So what's fascinating about this is us taking a look at the answers, right? Again, A, B, C, or D, is that a public subnet, answer A, is a subnet with an internet gateway attached. That looks promising also. B, A public subnet is a subnet with a NAT gateway for outbound traffic, right? But do you need a NAT gateway if you are already in a public subnet? What's the very definition of a public subnet? And then C is a public subnet is accessible from the internet, which, actually is technically true, but by default is not true, actually, because by default, security groups will prevent someone from coming out from the internet into a public subnet. And then D, a public subnet is a subnet with a public IP assigned to every resource. Oddly enough, that is not necessarily true. You can actually have things sitting on a public subnet behind a firewall, and they don't necessarily have a public IP address assigned. So it's not necessarily required. So very interesting, right? Very subtle there. So if I were to take a shot at this, I would say that the one clean, clear definition I can say that is absolute must for a public subnet to be a public subnet is that it must have an internet gateway attached to it through a routing table. So I think it's actually A. And let's see. I see a couple people have also thrown their hat in the ring with me and said A as well. So let's see what the answer is. Right. Public subnet with an internet gateway attached, right? That's the cleanest answer. You'll get fuzzy questions like this sometimes on the exam where it's like, wait, but a public subnet is accessible from the internet. That's true, but by default, the security groups are going to block it, right? And then a public subnet does not actually have to be assigned to every resource. That's just something that you set either by attaching elastic IPs, or you can actually set that in the configuration for the VPC and or subnet to automatically assign public IP addresses. So it doesn't have to be that way. All right. Next slide, please. Okay. So, Sanjeev, I'll let you go after this one. What best describes EFS in AWS?
Yep. So we take a look at the options, right? The first one, content delivery network. So I don't think a store, Elastic File System, I don't think that's going to be part of a CDN. A distributed caching service, most likely not it. Relational database, it's not really a database. And this question I think is pretty easy because it's like, it's in the name, right? Elastic File System. So a managed network file storage service. So EFS is a storage service. It provides a file system network that storage that can be accessed over the network. So most likely D is probably the correct answer.
Yeah.
And
yeah. Let's see. Yeah, I see that most of people agree with you, right? There's a lot of D's here. Good. Yeah, we see Rahul and Usman and Bava and Vinod all said the same thing. They all said, you know what? We think D is it. Now, here's a question for you, though, before we move on. What do you think would be a service that would describe a content delivery network and a distributed caching service? What do you think that would be? Sanjeev, that was for you.
We can let the students answer.
Oh, can we? All right, let's do it. All right, so type in the chat, what service do you think would be a content delivery network and a distributed caching service, which is actually pretty much the definition of a content delivery network? Like a globally distributed, worldwide, using edge locations, content delivery network. What do you think that answer would be? Completely out of bounds here, by the way, from the answers that are on the screen. Yeah, there we go. I see Ethan posted and Amar posted CloudFront, right? That's pretty much AWS's flagship and only content delivery network, so it's good. Ramdas, Cloudflare. I like your sense of humor because with Cloudflare, it's a CloudFront, right? Cloudflare is a whole separate business. So good. Good. All right, next slide, please. Okay, so we're past the practice questions. Let's talk about next week's episode. So we're going to talk about billing and pricing. And if we keep going forward with the slides, you'll see that we're just going to talk about general billing. We're going to talk about billing specifically, some billing tools, for example. And we're going to talk about pricing. Now, Sanjeev, if you don't mind moving the slide forward so we can see the whole set. So we're also going to cover practice questions just like we did last time. And the next session is going to be our final session. So, if you want to see something more from us, you want to cover something, let us know. We'll be glad to do YouTube videos on particular topics. And we probably could be convinced to do more live streams if you're interested in something particular. So let us know. Okay, next slide, please. Okay, so now it's time for the special announcement. So if you haven't been paying attention, you probably want to open up your senses and really take this in, because if you are looking to pass the AWS Cloud Practitioner exam, this is going to help, okay? So the first 5 students who complete the AWS Cloud Practitioner course on KodeKloud with a 100% completion score and you pass the mock exam with a 95% plus score, so you can be anywhere from 95% plus, we are going to give the first 5 students over the next week a free voucher to take the AWS Cloud Practitioner exam valued at $100 USD. Okay, so what this means is that both for this week and the following week, a total of 10 students, so 5 this week and 5 next week, if you can meet this criteria, we're going to give you a Cloud Practitioner exam. So again, first 5 and next 5. So let's go into some specific details. So next slide, please. So number 1 is that you're going to turn into the live stream, which you already have. So for those of you who are here today, right, you are going to be able to play, practice, and win. And we're going to show you the link, right? Go to the next one. And so you're tuned into the live stream. And so what you're going to do is you're going to enroll, sign into KodeKloud, and get your access. And you can use any of the coupons that we have provided to support that and take the AWS Cloud Practitioner course and complete it to 100%. In the action of taking the course, you want to get a 95% on the mock exam, right? Which is at the end of the course. It's actually on the very end. So 95% plus. And then next, after that, what you want to do is you take a screenshot of your 95% score and you're going to post it on LinkedIn or Instagram with specific hashtags, specifically KodeKloud and AWS CP. So you need both tags, right? A screenshot with that posting plus both tags. And then last but not least, you're going to fill out the completion form. And what will happen is that when you put your email address in to verify your KodeKloud like email address that you use to actually achieve the score, you're going to put that in and the screenshot. And what we'll do is we'll figure out the 5 winners who are in that pool of users who have completed the completion form. And then we're going to announce them both at the next live stream, and we're going to announce them in some videos that we're going to announce within a week of each date. So today's the 17th. So by the 24th, we're going to announce the first 5 winners. And on the 24th, by the 31st, we're going to announce the next 5 winners for that. Okay. Now, let me show you a little bit about the form. So next slide, please. And you'll see the QR code right there. This is going to take you to that completion form, right? And so this is what you're going to see on that page that you click on with the QR code right there. It's going to take you straight into this web page, and you'll hit start. Next slide, please. You're going to fill out your name. By the way, that's my email address. If you ever want to catch me on KodeKloud, please feel free to email me. I will respond, actually. And then you're going to click OK. Next slide, please. And then what will happen is you're going to post the URL or the link to where you actually posted on your Instagram, your LinkedIn, or your threads. So we are including threads in this, where you posted your success and your achievement. Okay. Next slide, please. So a reminder, next slide, or you keep going, right? Is that you're going to tune into the live stream. You're going to enroll into the course to get 100%. You're going to ace the mock exam and get 95% plus. Then you're going to post your achievement on either Threads, Instagram, or LinkedIn. You're going to tag it with the tags listed here. You're going to fill out the completion form, and then you are now entered into the pool where we will pick 5 people, and you will get a free voucher, 1 of 5, to take the AWS CP exam, and you will actually enter that voucher into Pearson VUE in order to take in order to register and take for the AWS Cloud Practitioner exam. By the way, we show you in the course how to register for the exam. We actually show you in the course where to put the voucher, just in case you ever get lucky enough to get one, which, here we are, right? So I hope that's super clear. That QR code, again, takes you out to the completion form. But if you're there and you're doing it, you get a 95%, broadcast your achievement, fill out the completion form, and we'll take care of you. And winners will be announced at the next session. Okay. Slide, please. Okay, so now the floor is open, right? So floor is completely open to any questions that you might have for us. You can ask about the giveaway that we just talked about. You can ask anything about Cloud Practitioner. Pretty much if you have any questions about AWS, you can pretty much ask us. So, and I do want to note that, thank you for attending, but ask us any questions you want. Okay. I do want to call out, by the way, that someone said, want to thank KodeKloud team for you cleared the certified Kubernetes developer exam, and absolutely, Mumshad is amazing. We love Mumshad. He does a good job. Yeah. So congratulations on that. Learn DevOps. Okay. Scrolling through really quick just to see if we missed any previous questions. See a lot of answers here. Thank you so much for participating. Let's see. Can you integrate it with WAF? So early on, Mohammed, you asked if we could integrate, like I'm assuming networking in with WAF. So since CloudFront and the edge networking pieces are all kind of part of that edge network, and WAF is as well, you can definitely integrate AWS's web application firewall. As a matter of fact, if I remember from just a few months ago, when I was publishing my live AWS updates on YouTube, one of the things that has shifted is that it's now like a checkbox inside CloudFront, which you can literally click it, and it will deploy and integrate a WAF in with CloudFront with just a checkbox. Whereas previously you had to kind of like set up some integrations. It will deploy with the default set of rules, like the default set of filtering rules that AWS recommends. But do know that yes, it does. CloudFront does integrate with WAF if that's what you were asking. So I hope that answers that question. Okay. You were wondering what AI ops tools are there for AWS. That's a great question. Ram, does it kind of depends on what you mean by AI, like ops tools? I will tell you that there's, machine learning is probably one of the largest services sections inside of AWS. So it really depends, like, what do you mean as far as like tools to enable like DevOps operations on AI tooling? And I would argue that like pretty much anything that you use for DevOps on AWS is going to be useful for AI ops management, since everything on AWS is a service. So things like Systems Manager and CloudWatch and using CloudFormation, the CDK, Terraform, like even your third-party tools, right, are going to be very useful. So any of your DevOps patterns that you were previously using to deploy applications and services, they're going to be totally applicable for any of the AI tools that you want to use on top of AWS. So while I wouldn't necessarily look and say, hey, is there something specific there? I would say that any of the DevOps tooling is useful. Now, if you're asking like what generative AI tools are on AWS, well, that's a whole nother session in and of itself. Let's see, Sandy, what do you think? A session on networking? Seems like there was a request there.
I think we could do that.
Yeah. I think we can do that all day long. Yeah, totally. Especially with Sanjeev here, right? He's going to be able to knock it out of the park. Let's see. Usman, when will Solutions Architect Associates course be available in KodeKloud? That's a good question. So I can't really give you an answer. Let's just say that it's in progress. So you may see it under some varying definition of soon. That's all I have to say about that. Other questions? Anuranda, how about the exam is expired in September? Oh, that's a great question. So let me just take a moment because I want to be mindful of time here, right? Is that the exam does update in September 12th, September 13th. So that's the old version CLF01. We are actually releasing updates for CLF02 that you will see here shortly. So we know that some of you are actually taking the CLF01 exam before it expires. Do note that when the exam rolls over, we will have a new version of the Cloud Practitioner exam with the updates, including the shift in weighting and all that stuff. And actually, you'll see a video come out from us about the changes here shortly. So stay tuned for that. Stay on our subscribe and like our channel, and you'll see us publish out some updates for CLF02. Okay, I just want to be mindful that we got about 60 seconds. So I'm going to ask one more question, and then we're going to close it out just to make sure we take care of everybody. Are AI tools going to impact more in AWS in the coming future? That's kind of an opinion statement, so I'm going to throw this out to Sanjeev. Sanjeev, what do you think? Are AI tools going to impact more of AWS in the coming future?
More in AWS compared to other places, or just in general?
I think more like, is it going to impact how we use AWS?
Potentially, right? It could. I could see it happening, with the abilities. You could see that it could integrate it into a lot of different services to make things a lot easier for, AWS administrators, especially on the observability side, using AI to automatically detect things easily.
Yeah. I think we're going to see things get a lot, be easier to automate, just in agreement with what you just said. Let's see. Next slide, please. Sanjeev, let's get to the last one. And so let's see, the one after this one, after Q&A. So again, thank you for being here. It's been 45 minutes, so we want to be cognizant of everybody's time. Don't forget, we have a giveaway. We have 20% coupons, but the giveaway is for the free 5 AWS exam vouchers. Don't forget to subscribe to our channel. Stay connected with us on LinkedIn. Stay connected with us on YouTube. Stay connected with us on Threads. So see us there. And if you have any questions, just let us know. You saw my email address, but hit support up at KodeKloud.com or catch us on our Slack channel. We'd be glad to answer questions there. Okay. So thank you so much for being here, and we'll catch you next week at the same time, same place.